The third year October midterm test. This is question 9. It's a question on patterns, and when you work through this you realise it is primarily a quadratic pattern. There is one part of it to do with linear patterns. So you get yourself a pattern, and the key thing is to sort of notice what's happening with the pattern and how it moves on to the next step. And the key idea you have to see is that from the first one, what you're doing is you add on a set of squares on the sides that are visible. So what I've just now drawn is effectively stage 2, and to go from stage 2 to stage 3, again, it's a case of fitting a square on every side that is visible to the previous shape. And as you go through that as a process, you get the next shapes. So we have, as a result, we have a shape that has 25 squares, and the next one after that has 41. And just to appreciate, we started off with 1, 5, 13, and the fourth and fifth terms are 25 and 41. Now, my argument with any sequence is the first thing you should do is have a look at the sequence and think about what's going on with it. So if we think about the numbers 1, 5, 13, 25, 41, what is actually going on with that? What's actually happening to it? So in this instance, we're adding 4, we're then adding 8, we're adding 12, and we're adding 16. And as a result of that, we can see that the first level differences aren't constant, so it's not linear. And when we look at the second level differences, we see that they're constant, and so therefore we know this is going to be a quadratic sequence, quadratic pattern. And as we move on to the second part, we're going to deal with that as an issue when we're looking at the area, the number of squares used. Before we get to that, before we deal with that quadratic, we're going to just look at part B. Part B involves looking at the perimeter of the shapes. And it tells us the perimeters are starting off with 4, and then 12, and it carries on from there. If you look back at the drawings, you'll see the perimeters are 4, 12, 20, and they move on from there. And if we look at that sequence, we're adding on 8, and again we're adding on 8, and we have a linear sequence. So linear sequence, we're adding on 8, so we can say that it's got the 8 times table hidden inside there, and all we need to do is the 8 times table, represented by 8n, is for each one, if we take away 4 from each of the values in the 8 times table, we get what our sequence is. So our Tn expression is 8n minus 4. And as we move on to part C, using what we've already worked out, we've already discussed, if you look at the sequence for the areas of for the patterns, 1, 5, 13, 25, 41, and we look at the first level and the second level differences, we find a second level difference that is constant, so we know that it's going to be quadratic. We know that it's going to be of the form an squared plus bn plus c. So to work out the a, we take the second level difference and we divide it by 2. So in this case, 4 divided by 2 is 2. So we know it's going to be Tn is equal to 2n squared plus something n plus something. And the key idea about quadratic is it's made up of this multiple of the square numbers plus a linear part. So we're going to break up this sequence of 1, 5, 13, 25, 41, and we're going to break it up into 2 lots of the square numbers and separately the linear pattern. So looking at my sequence of 1, 5, 13, 25 and 41, I'm going to break that up. So I'm going to start off with the 2n squared. So 2n squared, so 2 lots of 1 squared, 2 lots of 2 squared, 2 lots of 3 squared, 2 lots of 4 squared. Feel free to use a calculator if you need to. Anyway, so that's my 2n squared. So my linear bit, the bn plus c section, well, I have to realise that that's, okay, well, what do I do to 2 to get 1? Well, I take away 1. What do I do to 8 to get to 5? I take away 3. What do I do to 18 to get to 13? I take away 5. And you quickly find that there's this sequence of numbers -1, -3, -5, -7, -9. So let's take that linear section and just work on that. So if we now look at our sequence, our linear sequence, so we're looking at just this linear bit here. We see that this linear sequence has a first level differences of taking away 2 each time. So we know that this linear section is made up of the -2 times table. So we have -2, -4, -6, -8, and -10. And again, so we look at this linear sequence. Okay, it's made up of the -2 times table. And what do I do to the -2 times table to get the linear sequence section? So -2, we're going to add 1 to get to -1. What we're going to do to -4 to get -3. We're going to add 1. What are we going to do to -6 to get to -5? We're going to add 1, add 1, add 1. So we have as a situation, we have 2n squared plus the linear bit, but the linear bit is made up of -2n plus 1. So overall, we have a Tn expression of 2n squared minus 2n plus 1. Okay. And the last part of the question is reasonably straightforward. We've already discussed it. We know this is quadratic. We know that because we worked it out. We had to work it out because we were given the fact that the second level differences were constant. So we know it's quadratic. We've already answered that question up here. And the reason being is second level differences are constant.